Okay, now we're going to look at page 9A, and page 9A gets us to decide when we should clear an equation of fractions and when we should just deal with the fraction. So, again, this is page 9A in your chapter 3-4 packet. So 2/3 x plus 5 equals 11. I only have one fraction. The best thing to do here is to subtract 5 from both sides, because we always undo addition first. And now I have 2/3 x equals 6. Well, now I can multiply, I have a choice. I can multiply both sides by the reciprocal. And if you remember to do that, that is the easiest. This goes away and we get x equals 9. But some of you would rather just solve things one way every single time. So now you should definitely subtract 5 from both sides first, because that will just make everything easier. But you could at this point say, well, what is my common denominator? Well, your only denominator is 3. So you could just say, let's multiply both sides by 3. So you get 2x equals 18, then you can divide by 2, and you get x equals 9. So either way you get x equals 9, but this way you don't have to remember to multiply by the reciprocal. You can always say clear your equation of fractions. Now, what you could also do, and I don't recommend, but you can, is you can say right away, okay, I see a fraction, I don't want to deal with fractions. I'm going to multiply everything by the common denominator. Well, 3 times 2/3 is 2x plus 15 equals 33. Then subtract 15 from both sides. So 2x equals 18, divide by 2, divide by 2. X equals 9. That's another way to do it. Okay? But I think in this case, when you just have one fraction, you should isolate the variable and either multiply by the reciprocal or just multiply by the common denominator. Now, 3x minus 2 over 4 equals 4. So this is one of those where I have an expression in a fraction and I have to protect it. So the last thing I'm going to touch is the 3x minus 2, which means the first thing I have to undo is the dividing by 4. I undo dividing by 4 by multiplying by 4. But notice I'm multiplying by my only denominator, which is 4. So I have 2 reasons to multiply by 4. Then I get 3x minus 2 equals 16 plus 2 plus 2. 3x equals 18. Divide by 3, divide by 3, x equals 6. Okay? Now, another type of fraction problem you will see is 1/2 times 6x plus 4 equals 1/3 times 3x minus 9. Now, I could multiply everything by 6 because 6 is the common denominator. But before I do that, I want to see if I will get rid of my fractions by distributing. And because 6 and 4 are multiples of 2, and 3 and -9 are multiples of 3, that means I will clear my equation of fractions by distributing. Half of 6x is 3x, half of 4 is 2, 1/3 of 3x is x, and 1/3 of -9 is -3. Now I subtract 1x from both sides. I get 2x plus 2 equals -3, minus 2 minus 2, 2x equals -5, divide by 2, divide by 2, x equals -5/2. Notice I keep my equal sign lined up. Okay? Now, for number 4, 2/3 x plus 1/4 equals 1/2. Here is a classic case of where you'd multiply by the common denominator, because you have 3 fractions and we just want to get rid of it. So here the common denominator is 12. So I'm going to multiply this by 12 and distribute. Multiply this by 12. This becomes 6. Here again, you can say 12 times 2 is 24, divided by 3 is 8x. 12 times 1 is 12, divided by 4 is 3. Or we could show 12 over 1 times 2 over 3 becomes a 4. 4 times 2 is 8. 12 over 1 times 1 over 4, and that becomes a 3. Now I subtract 3, and I get 8x equals 3, divide by 8, divide by 8, x equals 3/8. Okay, so these are different cases of how to handle fractions.